It's an honor and a pleasure to be invited here today. I come from Spain, so long way coming here, and yet I feel at home. This is a great conference that is discussing the topics that I feel are important for everyone. So this is my presentation today. I want to share with all of you how at PenPod we rethink AI thanks to being transparent. And I actually love many of the talks today. I think Mr. Anthony Neo was discussing also some of the topics I'll be covering today. For those of you who don't know what PenPod is an open source user interface design tool that you can use over the web, but of course you can self-host. So if you're familiar with Blender or Godot, then you can think PenPod as the equivalent, but for designing UI design, user interface design, the things that actually interact with humans when you're using an app or a web. So today I want to discuss with you 3 ideas. I'm going to make sure I have my notes visible. It's going to be not technical. My talk is not going to be very technical, but I will discuss technical concepts. The first idea I want to share with all of you today is that user interface is very complex. It is a very complex problem. And I'll tell you why in a minute. The second idea I want to share with you today is that if we want to stand a chance around cracking the user interface problem, then we need open source, open standards, interoperability. We need to be very transparent about all the tools and the formats and the files that we use. And the third idea I want to discuss with you today is that to prove all that, I've brought evidence. I will show you a demo of what that looks like towards the end. So let's start with the first idea. This is made in PenPod. This is a typical flow of how a user journey looks like. This is some application, and we are documenting here how the user goes from one part of the application to the other. You can see very clearly that it is non-linear. This is not a film. This is more like a video game in the sense that you interact with the software. So this is describing one of the many flows. Actually, you can see, I don't know if you can see it, but there's flow 9, flow 10, flow 7. Different flows are being described. And this is a typical technique for user experience professionals to document how an application actually behaves through user interaction. So I think it's important when you see this to understand that an app or a web is an interactive artifact that has a bit of memory and a bit of context and has an identifiable user. I'll explain this. So I said interactive. Interactive in the sense that there are some events that are being triggered. It is reactive, it is live. It is an artifact in the sense that it has some boundaries. It is the work of someone, of something, and has some boundaries. It is not completely fluid. It has to run in a certain environment, and if it wants to go beyond those boundaries, it has to connect to other pieces of software. Of course, when I say it has memory, it means that normally you will extract data that existed before, perhaps in a database. And it has context because it might know what time is it, or the location. And finally, normally, we have an identifiable user. Even if the user doesn't have a login and password credentials, there is someone interacting with the software. All these things make user interface a very complex subject when dealing with large language models. I'm going to show you, by the way, all that I just said is equally valid for this. This is also a user interface. It's just that it's a text user interface. This is using a terminal interface. And in this case, this software is allowing me to interact with my source code. So this is a very elegant way to not use a mouse, just the keyboard, and interact with my Git repository. But modern UI doesn't look like this, right? Modern UI looks very complex. And I'm going to give you an example that illustrates why UI is such a complex artifact for artificial intelligence. This is a modern user interface. And this is this is a video that I have. So here we are seeing a speed run of someone designing. It is not relevant what is going on. Just want you to understand how complex the whole interaction is, how many things are happening at the same time to achieve a final design. You see different metaphors here. We have the left pane, we have the toolbar at the top, we have a color palette at the bottom, we have the right pane that edits properties. And then there was someone, if you see it, it was very quick on purpose, that was managing all that at the same time. There was some person that was interacting with this very complex user interface. What is interesting also about user interfaces is not the fact that they are complex like this and that you can actually cope with it. There are certain behaviors and patterns that you learn so that when you come to this user interface, you understand what's going on. Some software tools want to go beyond what is familiar, and they understand the risk of doing that, but sometimes that is exactly what you need. You need to create new user interfaces that were not conceived before to solve new problems. And I want to give you an example. It's a fun example to show you a second video, which is this same user interface, this very same user interface of PenPod, but 4 years ago. Do you want to see it? 4 years ago. So we have another video showing now. But you can already see how it looked like. So we will have this other video when the tech team is able to do it. While they do that, you can see that it was, here you have it, another speed run. So user interfaces and UX in general is even not as static for the same product. PenPod 4 years ago looked like this, but PenPod today looks like the past video. It is really complex to understand UI in general. And one of the reasons it is very complex, it is because part of the computation of what's going on only happens in our brains. A lot of the interactivity that is going on, and particularly for user interface design, is not codified in the design. It is actually codified in our brains. We are compensating for the lack of information with how we think about a design. Now, it gets even more complicated. Remember I said the first idea I want for you to take away from this talk is that user interface design is very complex. Here you have a traditional, to the left, a very traditional card in a design, right? We have an image, we have a favorite action, and then we have some information below. Well, let me tell you, and this is, I think, very familiar also for the Blender people, that a visual rendering like that might actually come from very different codified structures. There is no one-to-one in visual code in user interfaces. For instance, to the right you can see one of the many examples you could get this final visual rendering. In this example, I want to point you to the order property there that says -1. Do you see that -1? That -1 is what is actually doing that. The CSS properties making the image be up. It is a matter of taste. Other front-end developers might decide that it's not order -1. They're going to achieve that positioning of the image in a different way. But perhaps this person was thinking of other devices and other contexts where this card should be responsive. And this -1 will behave better and will be more flexible to unforeseen media. So how do we solve this, right? It's how do we codify user interface if we have all these problems about our brains doing a lot of the work, and actually there's no biunivocal relationship between a user interface and the code? Because let me tell you, this is so complex that we have all these laws of UX. Do you know these laws of UX? Anyone here knows laws of UX? These are basically cognitive laws about how we understand a user interface. They are expressing the different approaches that you might want to take if you want to be successful at creating user interfaces that humans will use. Some of them describe how important it is that similar objects have similar shapes. Some of them might discuss how where things are matter, hierarchies, relationships, etc., etc. So these are being taught when you want to be a professional UX designer, because if you don't follow any of these rules, you don't need to follow really all of them, but if you follow none of them, you're probably going to create chaos that nobody's want to use. It is amazing, and all this is really cognitive theory. It's about how we think about the interaction with the world. Some of them have evolved over time, and some of them are quite static. All right, so that is the first idea. I hope I convinced you about how complex UI design is really. Now, how do we solve this? I said open source, open formats, open standards, where there are ways to look at user interface design that are modern ways to look at it. And there are 3 ways, but mostly 2. I will describe all 3, but I want to emphasize the first 2. And the first one is what we call declarative design. Declarative design is our way to express the intended result only by the rule that has to be met, but know how we achieve the result. And I'll give you an example. When you go outside, you see road signs, right? And you might see a stop sign. The stop sign, and in general all road signs, are declarative design, are following the declarative design principles, because it is a rules-based design. What the stop sign is telling you is very simple. By the time you get to the stop sign, you have to stop. Your speed has to be 0. That's the only thing that matters. Whether you go in a bicycle, by car, whether you go in a bus or walking, it doesn't matter. You have to stop. I don't care how you do it. Actually, if you go by car, you could perhaps accelerate to the point of then immediately brake. Or you can slowly brake the car. The stop sign doesn't care. This is declarative design principles. Most UI design tools that were created before PenPod don't follow this approach. They follow what we call the imperative design principle, which is basically saying it matters how you actually get to speed equals 0. And then you get speed equals 0. The whole thing, they care about the process. So much they get obsessed about the process. The problem with imperative design principles is that if another vehicle comes, another type of vehicle comes, you have to redefine the process to include that new vehicle. But the stop sign doesn't care about that. That is the power of declarative design. And this in this example, I'm showing CSS grid CSS layout. This is a way to create layouts and alignments with rules that are very flexible, that don't care exactly how you achieve that. And basically, you want to achieve certain rules, and that is what grid CSS layout is about. Also, Flexbox in CSS does that. So for those of you that are front-end developers or know about HTML and CSS, CSS is a perfect example of a declarative design language. We have it there, and that's an open standard. Here you can see an example. In Penpot, which is a UI design tool, we make sure that everything you design performatively, everything you click, all the options that are there for you are actually connected to the open standard. So by definition, or by design, no pun intended, whatever you design is already expressed in declarative design terms. So we covered declarative design versus imperative design. But I also want to discuss with you semantic design, taxonomical design. This is very important and very recent. So some of you might already know about declarative design, but semantic design, perhaps not so much. Semantic design is expressed in UI in the form of design tokens. Let's not confuse design tokens with tokens in machine learning or AI. They are different. It's the same term, but it hasn't anything to do with that. Design tokens are ways to express a design decision. A design decision can be a specific border radius, or a color, or an opacity, or a width. And you can have many, or even a text space, or a font size. So you have multiple types of design tokens, and you can create many of these tokens and combine them. I'll give you an example. You can have perhaps a border radius that is actually 2 times an opacity value that was created also as a token. So you have a relationship that is intentional about your design decisions. And this was not available, for the last year, for history really, until very recently. Actually, the W3C now published the 1.0 spec for this. So it's a draft standard, but it will become eventually a standard. Now, when you combine declarative design with semantic design, this is wonderful because you can apply rules that also have meaning, and you can maintain and create much more complex design systems. Design systems being the backbone of your design decisions, design components that you can reuse in your apps. Like in this case, everything is applied, declarative design and semantic. This is a very beautiful screenshot of things that are we use Penpot not only to design Penpot itself and other software, of course, you can use Penpot to design your own software, but also sometimes to do some research. So this is a very good example, very nice. And the third type of, let's say, design, but I think it's not as important because it's very old, is simply categorization, which means that if you have a design element, sometimes you want to have different variations of that design element. In this example, we can see a button, and you can see it is enclosed in a square, and you have really different versions of the same design component that will be expressed depending on the situation. So this allows for easy manipulation of the permutation possibilities. So categorization, semantic, and declarative. Okay, so now I want to show you examples. This is Penpot with our MCP server, using all this power of open source and open standards. And someone actually just scribbled that. And what we are doing is asking an LLM to be able to understand the design and create a final design using design components that exist already in the file. So elements that were already there. And through our MCP server, the LLM is able to find the right match for every single design component using declarative and semantic rules. And eventually, you see that it gets the final design. So all these elements pre-existed. I didn't show you, but all these elements pre-exist in a design library. And the way it is expressed allows the LLM to understand that. Second video. This is a design that has no structure, no semantic, nothing. And we tell the LLM, infer my decisions, find the patterns, understand how I thought about the design system, and recreate semantically, you can see the color palette there, how it's being created. Basically reconstruct my design, don't touch my design, this is my design, but find all the underlying patterns that exist. If my color palette, border radius, opacities, widths, whatever I'm using, text fonts, you can recreate, and you can see all those tokens being now created there. This means that now I can expand on my own design, reusing the things that I created before. And I think this is the last video where there is a point where it gets very confusing because the LLM and the human are designing at the same time. So they are basically real-time collaborating, right? You can see here we expanded into different themes. Now that we have declarative and semantic design, we can expand and very easily create the dark theme, a stone theme. You see that, right? Very, very simple. Of course, you direct the LLM to what you want, but you get consistency, autonomy, intentionality the way you want. This would take days. Now it takes minutes. And this is the last video. Here is where I was saying that it's happening at the same time. The LLM and the human are real-time collaborating. And here what we're doing is, okay, we already have that. Expand on the design elements that existed. I want new buttons. I want new components, new pieces to be able to expand my design system. Perhaps my design system started with just 5 elements and 100 tokens. I want it to be much more expressive, and I want it to have 50 new elements and, I don't know, 200 more design tokens. And this is a way where we're seeing how user interface design is evolving. Like, the designer doesn't leave the visual canvas. The designer is in control. And the LLM is being tasked with new ideas, new concepts that, through the lens of the canvas, appear directly into the canvas. And this is unique because one of the things I didn't mention is why all of this can happen. I said open source, I said open formats, but also because Pempot is so open that it has a full-fledged API that is giving away to LLMs and users. It is the plugins API. So LLMs are actually seeing the canvas, understanding everything as a plugin would do. Being extremely generous with your own platform, being completely transparent about what you can achieve, has allowed us to match both the foundations of our design approach with the open source natures of being interoperable. And this is what we can achieve today. Now, my excitement is not when innovation brings something that was expensive to become cheap, but rather when something that was impossible becomes possible. Here, I think we all can more or less see what's going on. We understand what's going on. But I think I love the unknown unknowns. Now that people will have this power and full autonomy and sovereignty, since Pempot is open source, that you can own it and you can self-host it wherever you want. What is going to become the new UI? What is the future of UI when you have the power to cope with so much complexity? You can be bolder. You can think bigger. And when you do that, you might start to be frustrated about just one form factor like this. Because with the power of LLMs and your creativity, you could actually expand beyond a tablet, a phone, or a big screen. It could be 3D, it could be different media, it could, who knows? Or, you know, going back to the talk about brain-computer interfaces, why not also think about that? You can do it now here. So I don't know what the future holds for us and for Pembot, but I know it belongs to you. So this is our gift to you, open source UI design tool for everyone to enjoy. Thank you very much.